On number 7, the numerator there is a fraction, but the denominator is not. So let's keep the top the same. Okay, and let's see here, the first numerator there is not in standard form, so I'm going to fix that. I'm going to put it in standard form. Negative 15r plus 15 over 15r squared times, you can make that denominator be a fraction. Just put it over 1 if it helps you visualize. So when you flip, there's a 1 on the top, and then I'm going to go ahead and factor out the 12, just to save myself a little bit of effort here in a minute. Okay, there's a GCF of 12 right there. Okay, so in the numerator, we need to factor out a negative 15. And the denominator, there's nothing to be factored there. And we already factored the second one. So we can cancel the r minus 1s. We can cancel the 15, but don't lose that negative right there. So what we've got left is a negative times 1, so that's a negative 1 in the numerator. And then we've got the 12 and the r squared left in the denominator. Okay, so that's what you do if one of them doesn't have a denominator. Just put it over 1 so that you can flip and multiply. You can do the same thing if that happened in the numerator. Obviously, it would just be over 1. You wouldn't flip it if it was the top. Okay, number 8 I wanted to look at just because there's a lot of factoring that needs to be done on number 8. So I'm going to go ahead and take out the GCFs in this first step right here. So we can take a 2 out of that first one. That leaves us with m squared minus m minus 20, and I'm going to run out of room. Over, we can take out a 3 in that first denominator, m plus 4, times, flip it over, so I'm going to factor that denominator first. I can take out a 9m, and that leaves me with, what, m plus 4. Sorry, I'm having to kind of cram it in there. You can't even see it. So m plus 4 is what we're left with up there. And then in the what becomes the denominator, we can take out an m squared. So we're left with m minus 5. Oh my goodness, I've never seen that happen before. Just move that right back up here. That's interesting. Okay. All right, so let's see here. Let's go ahead and cancel what we can cancel, and then we'll factor more. So we can cancel the m plus 4, and we can simplify the 9 over 3, and we can simplify that m with the m squared. So let's see what we've got left. In the numerator, we've got 2 times 3, so that's 6. And then I need to factor the m squared minus m minus 20. Now, here's where it's really helpful to kind of use the denominator to help you out. I mean, this one's not really that hard to factor. It's 5 and 4, negative 5, positive 4. But if you were struggling with it a little bit, notice there's an m minus 5 in the denominator, so a lot of times things cancel, so, you know, that should kind of point you in the right direction. What do we have left in the denominator? We've got an m left, and we've got m minus 5 left. Yes, that's supposed to be a minus 5 right there. Okay, so the only thing left that we can cancel are the m minus 5s. So we've got 6 times m plus 4 all over m left for that one. Okay. Any questions about these? Really just relies upon your factoring. Okay, flip your paper over. Let's look at 9 and 10. Okay, so all of a sudden, in number 9, that numerator has 2 fractions in it. So what we're going to do is we're going to get a common denominator in the numerator. Okay, so in the numerator, we have a denominator of 3 and we have a denominator of x. So if we need a common denominator, that means the first one needs the x and the second one needs the 3. So don't forget, we multiply each of those top and bottom by what they're missing. So we now have x times x is x squared minus, because that was a minus sign in between those two, 3 times 3 is 9, and that's over a denominator of 3x. Now, the denominator is fine. It is a single fraction already, so we're just going to leave it the way that it is. And now we're going to handle it just like we handled the other problems. We're going to keep the top the same. Is there anything that I can factor in that numerator? X squared minus 9, right? Difference perfect squares. Let's go ahead and factor that out. X plus 3 times x minus 3. Leave the 3x. Okay, times, flip the bottom over. And there's nothing to be factored in that one, so we just leave it the way it is. But we can cancel our x minus 3's, and we can cancel those plain x's. So in the numerator, we're left with x plus 3, and in the denominator, we've just got the 3 left. And remember, we cannot cancel those 3's. Okay? You cannot cancel those 3's because the one in the numerator is attached to the x plus 3. Okay, let's look at number 10. 1 over PQ, so that's not a problem. That's a single fraction, so we just leave it the way it is. The denominator, though, we need a common denominator. So the first one's missing the Q. The second one is missing the P. So when we combine those, we've got Q minus P over, let's see here, I do alphabetical order, so PQ. Okay, so we have a single denominator now. We can keep the numerator the same, flip the bottom one over, and multiply. You cannot change the order of the Q minus P. Okay, well, you can, but the P has to be negative, the Q has to be positive. We can cancel the P times Q. So we are left with 1 over Q minus P. Okay. Let's do a few more examples like this. Make sure that we got it. Let me make sure that my thing got that. Okay. Yep, it did. All right, let's clear this. Okay, let's look at 11 through 14 here. All right, so number 15, wait, 15, okay, that should be number 11. That one caught me off guard too. That should be number 11 right there. I don't know why it's 15. Okay, so the numerator, we're good, okay? So we leave it the way it is, 5 over 4, because it's a single fraction. Now the denominator, let's look at this one. Don't forget, it looks like those are two completely different denominators, but are they really that different? No, they're really not. If we factor out this 4 right here, they both have the n minus 4. So that means the only thing that we have to fix is that we need to make that first one, we need to add or multiply in the factor of 4. So what we've got is 80 minus 5 over 4 times n minus 4. So keep the top the same, flip the bottom over and multiply. So we need to simplify the 80 minus 5. So that's 75. So we can cancel the 4's. And then we can simplify 5 over 75. And what is that? 17? 15? 15. Thank you. 15. Okay. So in the numerator, we've got n minus 4. And in the denominator, we've got 15. Okay, number 12. Numerator, we're good. Single fraction. So we're good right there. Now, be careful with this. In the denominator, that 1 doesn't have a denominator at all. So it needs to have the same denominator as the other fraction there in the bottom. So we need to multiply top and bottom by w plus 2. So that means we've got w plus 2 times 1. Multiplying by 1 doesn't do anything. So it's just w plus 2 minus w when we combine those numerators. Okay. If you need to write out that intermediate step where they both have the same denominator, that's fine. I'm just kind of skipping that right now since that's not really our focus. Okay. So let's see here. We've got w over w plus 2. Keep the top the same. Flip the bottom over and multiply. So w plus 2 is now in the numerator. When we simplify that, w plus 2 minus w, that just leaves us with 2. So the w plus 2's will cancel, and this all simplifies down to w minus 2. All right, let's keep going. Number 13. In the numerator, those are two separate fractions. So the first one needs the b squared. The second one needs the a squared. So let's write out what we've got there. We've got b squared minus a squared over, I prefer alphabetical order, a squared, b squared. Over, notice I like to make this main fraction line, I make sure that I exaggerate it, that it's bigger than my other ones, just to help me visually see what I've got in the big numerator and the big denominator. Okay, in the denominator, the first one needs the a, and the second one needs the b. So we've got a plus b over ab. Bless you. Alrighty, so let's factor as we are flipping, because b squared minus a squared is the difference of perfect squares. So that's b plus a times b minus a over a squared b squared times, when we flip it over, ab is on top and a plus b is in the denominator. Now I know it doesn't look exactly the same, but b plus a and a plus b are the same thing. Okay, the order of addition does not matter. So we can cancel those factors out, and we can cancel out one of the a's and one of the b's in the denominator with the ab in the numerator. So what we are left with is b minus a in the numerator and a times b in the denominator. All right, 14, here's another one with these ones on there. So we need to multiply the first one by n. So we've got m minus n over n over, we've got to multiply by n in the denominator as well, n times n. So we've got m plus n over n. So here we go, m minus n over n times n over m plus n. So the n's cancel, and that's all we can do with this one. We cannot do anything else with m minus n over m plus n. Okay, now for the last two, I'm going to show you, sorry, I want to make sure I got that. For the last two, I want to show you a slightly different technique, but it gets you to the same answer. Okay, so for the last two, I'm going to look at all four of these denominators. Okay, I've got 4, I've got 4b, I've got b, and 4. So if I look for a common denominator between all of those, it's just 4v. So I'm going to use a different color so y'all can kind of see the difference here. What I'm going to do on this one is I'm going to go through and I'm going to multiply every numerator by that common denominator of 4v. Okay. Now, my goal here is that I'm getting rid of all of my, what I call little denominators, okay? Because if I look at this first piece, 4v times 1 over 4, I can cancel the 4. So all I'm left with there is v. Plus, for the second one in the numerator, the 4v's cancel, so I'm just left with the 1. Okay? In the denominator, for the first fraction, the v will cancel, so 4 times 1 is 4, plus, for the second one, the 4's cancel, so that just leaves me with v. At this point, I would look to see if I can factor and cancel anything. Nothing factors, nothing cancels, so I'm at my final answer. Okay. Now, we would have gotten to the exact same conclusion if we had gotten a common denominator in the numerator and gotten a common denominator in the denominator and flipped and multiplied. A lot of times, though, this ends up being a little bit quicker. Some people prefer this method, some people prefer the other method. Personally, this is what I was taught, so this is what I'm used to. I think it does go faster, so I prefer this method. But as long as you do them both correctly, you should get to the same conclusion. So let's do number 16 this way as well, and you can decide which one you prefer. So if I look at all 4 of those denominators, I notice that I've got a plus 3 in a couple of them, and if I factor this second one up here, it also has a plus 3. And then I've also got a factor of 5. So I'm going to go through and I'm going to multiply my numerators. I'm not trying to get a common denominator anymore, okay? I'm not trying to get a common denominator. I'm trying to eliminate all of my little denominators. So I multiply each numerator or each term by the common denominator for the entire expression. Okay, I multiply each term by the common denominator for the entire complex fraction. And I'm trying to eliminate my little denominators. So for the first one, I've got a plus 3 in the top and in the bottom. So I've got 5 times a squared left for that first term. Plus, I circle my pluses and minuses so that hopefully y'all won't forget them. For the second one, the 5 and the a plus 3 cancel, so all I'm left with is the a squared. There's no more denominator up there, okay? I got rid of all of them, so now I'm just moving on to the big denominator. For the first term, the a plus 3's cancel, so I've just got 5 times a, plus, for the second one, the 5's cancel, and I'm just multiplying 1 times a plus 3, so multiplying by 1 doesn't change anything. I'm just going to drop my parentheses. Now I've got some like terms I need to combine. 5a squared plus a squared is 6a squared. In the denominator, 5a plus a is 6a. Now, be careful with this. I cannot simplify the 6a squared or the 6a, but what I can do is I can factor out a 3 in the denominator, and now that it's in factored form, I can simplify the 6 over the 3 to leave me with a 2a squared in the denominator. Or you can look at it from the perspective of I can divide all those terms by 3, and that's the result. Okay? So you decide which method you want to use, which one works better for you. Does anybody want me to like go back and do one of the other problems using this method? Do y'all want to see more of this, or do you think you've got it, or you've decided which one you like better? We just want to try a few, see how it goes. Let's do that, okay? So on your